This is our prototype DC power system that we're working on. We've been approached by a number of our customers and clients about ways to generate power more efficiently and effectively. As we have installed, literally thousands of DC power systems over the years. We've found that there is a need to look at this problem deeper and think about how we can do this more efficiently. We find that most communication facilities require, not all communication facilities should have some form of backup power to maintain operation in the event of a loss of power. And as our company's worked in many countries throughout the world, we've found that this is even a greater need in developing countries. Example, we recently have been installing numerous sites in the country of Haiti. And in Haiti, the power is very unreliable. In fact, our DC generators, our diesel gensets run in parallel. We set these units up in parallel, and they run 24/7 to maintain power at essential communication facilities. Sometimes we get some off-grid power. We get some grid power that supplements our off-grid power, but for the most part, our off-grid power system powers the site and maintains and allows the communication to continue despite poor electrical service. The challenge that we've found in these sites is that the units obviously run 24/7. They are under relatively low level of load. They don't have an high load, but they need a high level of reliability. And as such, we felt it was important and prudent that we look at some alternative ways of creating not only more reliable power, but also power that was more efficient to generate. And more importantly, power allowing our diesel genset to work under a load better. And so we've developed, in cooperations with Cummins Power Systems, a solution. It's not Cummins Diesel. It's Cummins Power Systems. A solution that will allow us to for our diesel engine to work more efficiently. Our engine is developed in a way that we are able to continually monitor its output power capabilities and adjust as we need the speed of the engine actively as we have variation in load. We, more importantly, have developed a system that allows our engine to work under a full load rather than partial load. And in doing this, we're able to create a more reliable source of power. Ultimately, we are able to run the engine less because it is when it is running more efficiently, and as such, we are then ultimately reducing, because it is running less, we are minimizing the wear and tear on the vehicle, on the engine itself. So these are really all little small optimizations in various different sets of efficiency. The same amount of energy is required to be generated. It's just the way the energy is being generated is being done more efficiently and effectively. So the unit is turning out to be quite efficient, and it's not a matter of that we're not violating any We have not come up with any new great way to make power. We are just doing it in a smarter way. We're doing it in a more efficient way, and we're ultimately making the unit more reliable.